trajectories are probably the most complex type of spatial temporal data because they are the ordered sequences of geospatial locations and timestamps of moving objects over space and time, such as GPS trajectories of a fleet of taxi or trajectories of massive movement of people over urban space. So a lot of these real-world problems in urban environments are a mixture of different data types, which make these problems even more complex. And hence, there are certain methods like cross-domain data fusion and stuff to combine these into one unifying data. So for example, like if you look at the broad traffic prediction, you have the infrastructure, the road network. They have their own sort of static properties like fixed number of lanes, the speed limit, and etc. So the bridge type and road type and highway type. But at the same time, you have dynamic features like the cars traveling through them. So the speed changes with time and throughout the rhythms of the day. And also the same thing for incident prediction. You have the boundary of the neighborhood, the number of buildings in there, the types of the district. Is it a commercial district? Is it a neighborhood, a residential neighborhood? And you have the population dynamics going on in that neighborhood. At the same time, you have the instance type that changes with day and night, also with the seasons. And trajectory prediction is probably the most complex one that you have. Moving people, the group dynamics, whether individual is moving alone or with a group of people, so weekday, weekend patterns, and etc. So it gets more and more complex, and therefore in this talk alone, we'll be able to only talk in details the two problems: traffic speed prediction and crime incident prediction, due to their relatedness and also somewhat being more simple than trajectory prediction. So the first problem is, how do you go about predicting fine-grained traffic speed over a big complex network of road networks in the most extensive way spatially, and also in how do you predict ahead of time, in 5-10 minutes ahead of time? So if you want to route a fleet of autonomous vehicles. So the problem is, I got a lot of data from Uber. I was in Pittsburgh, Pennsylvania in 2015 doing my internship. So from the data, we have sensor readings in certain, if you look at this little figure, so this is the location of the sensors of certain road segments at every 5-minute snapshots. So the problem is, how do you go about infer to the whole network the distribution of the speed to the whole network, because you can't practically place sensors everywhere. And how do you go about inferring in a few minutes ahead of time so that you can even plan for your fleet of autonomous taxis, so to say, how to optimize for the speed and how to do real-time speed prediction. So that's a problem, spatial temporal inference. So for the problem, I employed a method called Gaussian process, which is basically a nonlinear prediction or interpolation, if you will, that takes advantage of the property of being spatially correlated of these sensors, because obviously if you look at the road network, so speed over one particular road segment will be influenced by the incoming flow of the traffic through the other branches of the network, and so not every other edges in the graph would have the same influence. So that the spatial influence, also the temporal influence, at what time in the day, and there's certain events that might fit into the network effect. So Gaussian process has certain advantages of being able to model the complex behaviors that are spatial temporally correlated over space and time. So that's the main advantages of Gaussian process. So in short, as I said, it's a nonlinear regression technique that encapsulates the concept of closeness in space and time by kernel functions, which can further use to incorporate features, static features such as infrastructure, etc. At the same time, it's also a Bayesian method. Now, I don't want to go deep into all this stuff because it's a bit too technical. But I mean, briefly speaking, you can do Bayesian inference on GPs or do Bayesian updates without retraining the whole model, because training is expensive. If you knew something's happening, you can update the parameter in a Bayesian inference fashion, which can be much faster than retraining everything in light of new evidence of your new data, new event, etc. So that's the main advantage. Now, I'm not going to scare you up with this, but this is just to say that you are able to use kernel functions in Gaussian processes to capture the complexity of the network, of the directedness of the graph, of the spatiotemporal correlation of the graph, of the network structure. At the same time, you can also incorporate static features of the infrastructure using this particular kernel method. So without going further into it, and we were able to evaluate the proposed method of what we call the local Gaussian process, which something more complex, but essentially it's the Gaussian process on clustered road segments over space and time. So we were able to do inference over the whole network at different time steps in the future, and we're able to evaluate with state-of-the-art alternatives, and we were able to show that our error rate is among the most competitive with pretty good performance, and when we cross-validate with the actual data. So the results were published in an IEEE journal last year, in the Journal of Big Data, special issue on urban computing. So that's the first problem. Second problem is crime incident prediction for urban law enforcement, which is a consultation work between me and my advisor back then for a national law enforcement agency here in Singapore. So crimes is an obvious effect of urbanization and population growth, because as population density increases, you have more people moving in certain neighborhood, and therefore increases incidents and certainly puts a lot of stress and strain on the local law enforcement agencies. So the challenge is how to guarantee the quality of service, the quality of law enforcement service, in light of these trends, of rising demands and this urbanization trend. And for the problem, we were provided with large-scale database of crime incidents that provide fine-grained details of when incident happened, the context, description. So it's a big database from National Law Enforcement in Singapore. So therefore, I was able to make high precision, high fidelity prediction of crime incidents using machine learning with pretty much the same technique. So as I said before, the law enforcement problem wants to guarantee it at any time, any point in time, at any neighborhood, at any sort of defined neighborhood where you have certain manpower resource, like number of cars. How do you guarantee no more than alpha fraction of the incidents cannot be responded within 15 minutes time? So that's the optimization problem underlying the problem. How do you go about predicting the incident, the trends of incidents, in this particular place, in this particular time, so that you can place the resource in the right time, the right place, and hence the quality of service can be guaranteed. So as I say, the database is pretty big. With Singapore is a pretty safe place. So we got a couple of years of incident reports with half a million reported incidents, from emergency phone calls, from police reports, etc. Each incident has a lot of features, spatiotemporal features, as well as the response tactics, and a lot of stuff that I can't even publicly say. And the metadata containing the police neighborhood, the boundary neighborhood, the sector boundaries, and police deployment, where they go around patrolling, deploying those resources. And I was able to use the same techniques of Gaussian processes with kernel and features that capture the similarity of certain neighborhood boundaries and certain space and time features. Also, whether it's weekend or weekday, and also discretize the time scale, and also count down of instances in each spatial temporal bin. I was able to predict in pretty much, like, given this bin, can you predict the neighboring bins, and can you predict ahead of time, so that the resources can be planned in advance. And we did comparison, and we was able to come up with pretty competitive models compared with the other state-of-the-art models, and was able to show that our models can realistically capture the distribution of the number of incidents in certain neighborhoods, and it was enough for the police force to do the resource planning. So that's the problem. So basically, in a nutshell. So I just want to introduce the problem on a very, very superficial, in a very superficial way, because I can't really go deep in this because due to time constraint. But there are certain takeaways that I would like you to have after this talk. So it's urban computing takeaways. So what is urban computing about? So it is about 3M. So it's about big data, big challenges in big cities. So solving big challenges using big data in big cities. It is about data management. So how do you go about fusing cross-domain data, craft data, social network data, online and offline human behavior, as well as trajectories, what they do in the real world against what they do in online world. About data mining, how do you get insights for the data? How do you group people and clusters people, and how do you learn and predict the pattern of behavior? So it's about machine learning, and it's a win-win-win solution. So it's win for the people, for the city, and for the environment. If you put these three together, it's 3 BMW. So that's the takeaway. Thank you very much.
Questions, please.
Have you thought about bringing together your two areas of research to basically put police patrol cars where they can reach the possibly occurring crime scenes as quickly as possible?
Yes, exactly. That's actually part of the work that I did not mention. So how do you go about predicting the incidents, and how do you go about predicting the response time? So given the traffic condition, can you optimize for the response time? You can give a prediction of the travel time for the police cars. So that was also part of the research that I did not mention. Yeah, so actually, one leads to another.
Cool. Thank you.
Other questions, please?
Question about city brain that was done by Alibaba. Have any other opinions on their projectors? Pretty similar to what we are setting now.
Can you repeat again?
All right. City brain by Alibaba.
Oh, okay.
Yeah. They are doing something that is really similar in large-scale cities.
Okay.
So what is the opinion on those?
To be honest, I'm not aware of the city brain from Alibaba, but I know there are a lot of things doing this, and as I probably have mentioned, the pioneering group is Microsoft Research Asia in Beijing, who proposed the whole problem and the whole framework, and who did a lot of research work on cross-domain data fusion, trajectory prediction, and all these sub-problems in urban computing. Yeah, but I don't know much about Alibaba.
I have a couple of questions for you.
Okay.
Of the big challenges you put forward, which one do you think you find to be perhaps the simplest to solve? And secondly, which one do you think would have the biggest impact?
Can you repeat the first question, please?
Of the problems, of the
yes.
challenges, which one do you think is the easiest, if you have to guess?
Right. Really, there's no problem that's easiest. So they're all interlinked, so one leads to another. If you think of the urban system as a complex system, so everything is interrelated. And there's nothing that's really, as I say, the problem, law enforcement calls for the problem of your deployment. How do you deploy response time given the traffic conditions? And also maybe incidents can affect the traffic conditions. So if you have crime incidents or whatever incidents that might disrupt the traffic. So everything is an organic complex system. So first of all, I don't think anything is simpler than anything else. Yeah. And what's the second question?
Which of the problems would you think would have the highest impact? The city.
Right. I don't know whether it's positive or negative impact, but what I'm imagining is that from my knowledge, I have been reading or researching on this particular problem, a lot of efforts have been put in linking online and offline social behavior. So how do you, given, say like your phone records your offline world behaviors, where you go at what time, and you have your online social network friends, how do you identify, pinpoint individual and merge these two offline trajectories with online behavior social networks? So there's a lot of work going on, particularly in China, that I'm aware of. So that's, it's certainly so there are people who have the power to know too much about you. So there's a lot of concerns and problems about privacy, first of all, and so certainly there's a lot of impact when it comes to collecting massive data and knowing too much about individual citizens at any level. So that's a huge concern. So I think, but actively, that's something that's actively going on in this particular urban computing domain research. Yeah.
One more question.
With your crime prediction, what was the response from law enforcement? Did you work with them at all in terms of, using the results from the research?
Right. So the response that they are adopting the model, and it probably takes years to calibrate its impact on law enforcement, but there's growing concern of how do you optimize for the resource given this growing trend of population and stuff. How do you guarantee this alpha fraction of incidents cannot be responded in 15 minutes time? So that's the original question. But for the impact to be calibrated, it probably has to take years to know whether that quality of service can be maintained. Yes, exactly. So, yeah, right. Not only the population and infrastructure evolves, but the types, the nature of crimes, the incidents also evolve. So that has to be taken into account in the model. So it's not only the number of incidents, but also the type of incidents and how that evolves. Yeah, definitely.
So you work with mainly based on the accessing crime or the time response of let's say, a police car or whatever,
yeah,
to a specific area.
Yeah. Yeah, exactly. Yeah, I think there's a question over there.
We
Oh, okay, okay. Thank you very much.
So next up we have Vignesh.